Hey guys, welcome back. We're going to start lesson number 5. This lesson is on implicit differentiation. I'm going to split this lesson into 3 videos. All 3 videos are on implicit differentiation. The first video is going to be the introduction. The second one's going to just be more examples. And the third one's going to be a little bit more complicated problems. So before we actually get into implicit differentiation, let me just give you a little bit background of actually what it is. So what I'm going to do here is I'm going to write that the function y is equal to 5x squared minus 9x. Okay, so there's our function. And if I ask you guys to find the derivative of this, you actually know some notation now for derivatives. You would write y prime, but you've also used f prime of x. And briefly, we've talked about the d over dx. And this is the one I want to talk about. This is the one that's the most important. So notice that for this right here, the bottom is dx. What we're assuming here is that we're taking a derivative, which is the top part, but it's in terms of x. Everything's in terms of x. So what we're going to do today is we're going to take this one and we're going to add a y to it, dy dx. So we're going to take derivatives of every variable in our equation, but we're also going to remember that it's in terms of x. And this is going to make more sense when I start doing the problems. So if I ask you guys to find this derivative, you're going to do dy dx on the left. Because again, we're taking the derivative of y with respect to x. Well, the derivative of y is just 1. So it's dy dx. And then this is going to be 10x minus 9. Okay, so this is going to be the really important part for this, that dy over dx is equal to 10x minus 9. So that's the nomenclature we have to understand when we do the problems. So when we're looking at implicit differentiation, here's the guidelines for what you need to do. You definitely want to differentiate both sides with respect to x. So that's really important. Like I said, as I do these examples, this is going to make more sense to you. We want to collect all the terms that involve a dy dx. Again, I'll talk about that in a second. We want to basically isolate dy dx. That's really what we want to do. Step 3 and 4, just we can combine that and say we want to isolate this. So we want to get this by itself. So let's actually look at an example and then go over and discuss it. So I'm asking you guys to find the derivative of dy dx, and notice that for the first time, we actually have not just x variables, we actually have y variables, right? So what we need to do here is that we have to remember that we're doing things in terms of x. So we're taking derivatives in terms of x. Once we talk about related rates in the next couple of lessons, you guys will truly understand this. So we actually put related rates really close together with this lesson. So, after we do this, you're like, oh, related rates is actually pretty easy after that. So you're going to treat y cubed as you would x cubed. You're going to find the derivative of y cubed just as fact if it was x cubed. So the derivative of x cubed is just 3x squared. So you're going to do the same thing. You're going to do 3, but you're going to do y squared. Now remember, ladies and gentlemen, that we're in terms of x here. So we need to add dy dx to our function. Because again, we're taking a function that has y in it. We've taken the derivative of y, but we have to remember that we're doing it with respect to x. There's no x terms here, so this term has to go. So again, we go plus. Again, looking at 7y. 7y is the same thing as 7x. The derivative of 7x is 7. Same thing, the derivative of 7y is 7. Again, we had a y here, so since we have a y, we have to take the derivative of y with respect to x. And then we're going to do equals, and then we're going to take the derivative of the right side. Well, this is a x cubed, so we're going to do 3x squared, and then we're going to take the derivative of x, because again, we did the derivative of x with respect to x. So now we're basically adding these little steps in here. So we're always going to be, they'll always tell you what we're doing in terms of, if it's implicit differentiation, it's always in terms of x. When we get to stuff like related rates, time may be another issue here. But if we look at this right here, we want dy dx. We're wanting to solve, we want to solve for these terms right here. We want this by itself. Okay, another thing that I want to say very quickly about this problem is that notice that this right here, dx over dx, this actually ends up being 1. We've actually, when we're taking derivatives previously, we've actually done this. We should have written this out every time dx over dx, but we don't need to do that because it's always 1. It's always 1. So whenever you guys do a term with an x, you don't need that. And as I go through the other problems, you're going to see that I'm going to actually not include this. So I need to get dy dx by itself. That's what I'm solving for, right? I'm trying to find dy dx. So if I gave you guys something like 3xy squared plus 7x, and I wanted you to solve for x, you would undistribute the x, right? You would take the x out. So that's exactly what you do here. You're going to undistribute the dy dx, and you're going to be left with 3y squared plus 7. And if I were to distribute this back in, then that's fine. We would get this thing back out. And then on the right side, I would get the 3x squared. Okay, because this is just 1, and then I'm okay with that. And so finally, ladies and gentlemen, once everything's all said and done here, then I want to get dy dx by itself. So this answer, dy dx, is going to be equal to 3x squared all over 3y squared plus 7. And this is your answer. It's going to look a little bit weird. It's okay to have x's and y's together. It's going to be expected. Okay, so let's try another one. Let's look at another example here. So this says dy dx. And so what I have students do that struggle a little bit here is that, okay, we'll look at every term that has a y in it. And anytime you have a term that has a y in it, you're going to add a dy dx to your derivative. All right. We chose a little bit more complicated problem here because if you look at this, this is going to be 4x squared y. And so what students don't understand here is that we have to use the product rule. This has to incorporate the product rule. So we're going to do 4, and then I'm going to go ahead just to make this simple. I'm going to do the 4 with the x squared. So my first term is 4x squared, and then my second term is y. So it's going to be the first times the derivative of the second. So remember, the derivative of y is 1 because the derivative of x is just 1. It's 1, but again, because I'm taking it with respect to y, I've taken the derivative of y with respect to x. So there you go. And then I'm going to do plus the second, which is y, times the derivative of the first. So I'm taking the derivative of 4x squared. Well, the derivative of 4x squared is just 8x. I do not have to do, I could write, if you wanted me to, dx over dx here, but I don't need to do that, and I'm not going to do that for anymore. So I want you guys to understand that when I'm taking the derivative of a function that has just an x variable in it, I'm not going to do dx over dx because it's going to always be 1. All right? So that's our first part. So what I've just done here in orange is just a derivative of that. So you want to be really, really, really careful when you're doing a derivative, especially with implicit. Don't forget about the product rule, the quotient rule, and all the fun rules that we've learned here before. Okay? So then we're going to do minus. We're going to take the derivative of 3y. Well, again, the same thing as 3x. It'd just be 3. But again, ladies and gentlemen, because we now have a y here, we've taken the derivative of a function with y with respect to x. Okay? And so we're going to set that equal to 3x squared. And again, I don't need to do anything else over here. Dx over dx is fine. And then remember, the derivative of a constant is just 0. So we're good with that. So what I want to now say is, let's look at what we have. So we have one term here that has a dy dx in it, and we have another term here that has a dy dx. So like when you guys are learning Algebra 1 and you're trying to solve for, y, and you would move everything else onto the other side, that's exactly what you do here. So we're going to keep these two things on this side, and we're going to move this guy right here. We're going to move this over here. It doesn't matter that they both have an x and y in it. It doesn't matter. We want dy dx to be by itself. So you're going to, like I said, you're going to get some really crazy answers, and that's totally, totally fine. So I'm going to go ahead and I'm going to do 4x squared dy dx minus 3 dy dx. And then on the other side, I'm going to do 3x squared, and I'm going to subtract 8xy. And again, it does not matter that there's x's and y's combination over here. We're good with that. And then, ladies and gentlemen, because you're BC students, I know you can understand this. I'm going to go ahead and just not show this step. I would undistribute the dy dx, right? So I would have dy dx, and so I'd have a 4x squared minus 3. And so when I'm trying to find what dy dx is, eventually, so dy dx, well, I'm going to leave my top term. It's 3x squared minus 8xy all over what I would have undistributed, which would be 4x squared minus 3. Okay? So again, the answer looks a little bit weird. I'm so sorry with my spacing here for these problems, but that's what you would do here. Okay, so let's look at question number 3. So in question 3, if you want to pause it and try to do it yourself, you can. But let's go with this problem. So there's 2 ways to do this problem. I'm going to show you the long way first, and then one of my students had a brilliant idea that's like, well, I did it this way. Can it work this way? And it actually does. So let's go and show you by doing implicit first. I'm going to go ahead and rewrite this as x squared is equal to x squared plus y squared to the 1/2 power. The reason I want to show it to you this way first is because I want you to see we have to use the chain rule. So we're taking the derivative of the left side, and the derivative of the left side is just simply going to be 2x, right? And again, you don't have to do dy dx here because there's no y's here, so we're good. 2x, done. The derivative of the right side, well, remember, we have something raised to a power, so we have to use the chain rule. So we have to do 1/2. Remember, leave everything inside of the parentheses alone, everything inside the parentheses alone, to the negative 1/2. All right, and so we're going to then take the derivative of what's inside. So we have a 2x plus, and then again, this is where students always mess up. It's going to be 2y, but we have to remember that we're taking the derivative of something with the y in it, so now we have to do dy dx. Okay, so I want to really make sure that we're good with that. All right, so hopefully that makes sense to everybody. And remember, we're just trying to get dy dx. We just want to isolate that. There's only one term, there's only one problem here that actually has the dy dx. So what we can do here is we can go ahead and simplify a little bit more. Well, I'm going to go ahead and multiply by 2. And so I'm going to get the 4x. And then notice that this would be in the bottom, right? This would be in the bottom, so I'm going to go ahead and put it to the top. So this is going to be x squared plus y squared to the 1/2 power. Hopefully you guys followed along with me there, right? Normally this would be 1 over the x squared, and so I'm just going to move it to the top. And so now what I'm left with is 2x plus 2y dy dx. Okay, so I just moved this to the bottom, and then I realized that this is a big old product, and so I just cross multiplied essentially. And so all I want to do now is I could also simplify right now and notice that everything has a 2, everything's even in it, so this could be a 2 and this could be just 1 and 1, so that's a nice little thing for me to do. And so finally my answer, that's going to be kind of crazy here, but dy dx is going to be equal to, so I'm going to go ahead and write down what I have right here. It's going to be 2x, and let's go ahead and just do the square root of x squared plus y squared. And then I would have subtracted the x, right? Subtracted the x, so I'm going to do minus x, and then I'm going to then have a y. You guys can look at my answer key and see like all the other steps out. You know, this is a video, so I'm doing a couple steps in my head here, but this is the answer. And like I said, it looks really weird, but it's totally okay. It's only okay to do. Okay, so that's the crazy long way. That's the crazy long way. So what I'm going to do here is I'm going to hold on and keep this answer here, but I'm going to erase all this other stuff. But hopefully, again, that will make sense to you. So one of the reasons that I absolutely love teaching calculus is that I'm just so amazed by how my students can just look at things in a different way than I would and think, oh, I did it this way. And then sure enough, it actually worked. So what the person did is they was like, let me square both sides first. Let's square both sides, right? Well, let's square both sides. Look like that. I don't want to do that. So I'm going to square both sides. And we can absolutely do that, right? We can absolutely do that. So this would be x to the 4th. And this would be x squared plus y squared. So pretty easy problem to do first. And so let's now take the derivative of these problems, right? So again, it's going to be 4x squared, or 4x cubed, is equal to 2x plus 2y dy dx, right? Pretty easy stuff. I'm going to go ahead and do one extra step here. I'm going to divide everything by 2 and I'm going to move this x over. So I'm left with 2x cubed minus x equals y dy dx. Okay, so hopefully everyone can follow that pretty well. And let's now say what our answer is. So dy dx is equal to 2x cubed minus x all over y. A really nice way of doing that. So someone would be like, hey, wait a second. Wait. These are not the same things. These are not the same things. Well, yes, they actually are. Yes, they actually are. And this, again, why it's brilliant for this. So let me go ahead and get all this out. If you guys notice that this answer at this top here, this top part right here, we have an x cubed. Right, so the 2 matches up fine, the x and the minus x matches up, the y matches up. The x It's cubed doesn't. Well, we have 1x here, right? 1x here. Well, what is x squared? So we're left with an x squared. Well, what is x squared equal to? Well, according to down here, x squared is equal to the square root of x squared plus y squared. And lo and behold, that's our given problem. It's telling us that x squared is equal to that. So these are the same problem. These are the same answers. So sometimes use simplicity. See if you can simplify it first. I'm always suggesting that you guys do that. Try to simplify as much as possible before using correct math, obviously, before you guys do it. All right. So let's look at example 4 and 5. We got 2 more in you here, and let's see what we can do with these next 2 problems. So for question number 4, it says find the derivative. Now this is with respect to t. Guys, it doesn't matter if this were x's, this would be x. So we're basically going to say that anytime we have a function that has a t in it, we're just going to do dt over dt, which is really just 1. So if I'm taking the derivative of t cubed, that's just going to be 3t squared. And then yes, I should put a dt over dt here, but I'm not going to do that. I don't really need to do it for this particular problem. And now we go to this part right here. I'm hoping that you guys, what do we have to do here? We have to use the product rule, right? We have 2 functions, 2 variables that are being multiplied together. So we must use the product rule for this. So I'm going to change it up and do some pink. So again, our first function is t squared. Our second function is y. So I'm going to go ahead and write the first. And then I'm going to find the derivative of the second. Well, the derivative of y is just 1 dy dx, actually dy dt. Students ask, what if, you wrote a dx here? I don't think they're going to be that picky with it, to be honest with you, but it's always nice to write the notation correctly. All right, so the first times the derivative of the second plus the second times the derivative of the first. Students are like, well, why don't you have to write a dy dx here? Well, we didn't take the derivative of a function with y. We wrote a function of y, but we didn't take the derivative of that. So I don't need to do that. The only derivative that we're taking in the second part was in terms of t, right? We just took the derivative of t squared. And so we have this, and now we have negative 10y to the 4th. We're going to go ahead and use the power rule here, and we're going to do negative 40 y cubed. And again, because we took the derivative of y, we're going to do dy dt, and we're going to do this equal to 0. And the beautiful thing is, and another mistake that's constantly made, ladies and gentlemen, is over here, there's a constant, and students just automatically want to just throw the constant in here. So remember, if you have, it can be any number here, 9, 12, 15, whatever, you would put a 0 here. So don't forget about that part. I kind of lost my blue in this problem, so I'm going to go ahead and use it again here. So we have 2 terms. We have 2 terms that have a dy dt to them, and I want that by itself. So I'm going to isolate those. Now, I like to keep things as positive as I can. So hear me out here. I'm going to keep the 2 that's to the left. I'm going to keep the 3t squared plus 2ty on the left side, and I'm going to move both of these to the right, because then this becomes positive. Right, so this is going to be 40y cubed dy dt, and this is just going to be minus t squared dy dt. And the more practice you have in this, the better you're going to get, because now you already know the answer, right? You know what this answer is, at least I hope. I'm going to go ahead and do the 3t squared plus 2ty. And again, just like we did in example 1 and example 2, I would undistribute, right, the dy dt, and so I'd be left with 40y cubed minus t squared. And that's what dy dt is going to be equal to. Okay? I'm so sorry for all these boxes, these lines, but, it's about organization here. All right? So 4 down, 1 to go. Hopefully everyone's okay with that. Like I said, the more you practice this, the better you're going to become at it. So it's a lot of crazy stuff right there, right? If you look at that screen. All right, so let's go ahead and do example number 5. So for number 5, the first thing I want you guys to notice here is that now we have a square, a d squared y, and a dx squared. So this basically means we got to find the second derivative. The second derivative. All right. And so that's going to be your nomenclature for that. So if it's dny over dxn, then whatever that is going to be your derivative. Another way that sometimes they put this in here, let's say if you want to find, God forbid, the 17th derivative, they would have like find f17 of x. All right, and that's another way of saying 17th derivative. But that only works usually if you're doing the derivative of sine and cosine. You can do that pretty easily. Okay, so let's go ahead and find the first derivative. This is a classic example. Now, normally when they do these kind of problems, guys, if this is a question on the quiz or test or on the BC exam, they usually give you the first derivative and they actually find the second one because there's like really key important moment that you need to do when we do these problems. So let's go ahead and, for me to stop talking and actually do the problem. So again, what must we do here? Hopefully you said the product rule, right? The product rule. We have two terms being multiplied together, 1x, 1y. So I'm going to go ahead and again, I'm going to put the 2 with the x squared. So I'm going to do 2x squared. So it's the first times the derivative of the second. So again, the derivative of y is 1y. Oh, sorry, just 1, and then just dy over dx. I want to also say that this helps us really solidify lesson 4, right? It really helps us with the quotient rule, the power rule, the product rule, the chain rule. So well, we haven't done the quotient rule yet, but you guys get the idea with that. All right, so where were we? So 2x squared times the second, derivative of the second. All right, then we got the second times the derivative of the first. And again, I don't need a dy dx there at all because, again, I only took the derivative of in terms of x here. And then minus, this is going to be 12y squared. Again, because we took the derivative of y, we have to do dy dx. And then equals what goes over here? Hopefully you said 0, right? Not 4. Just like I said up here in this example number 4. Students see that number and they're thinking, yep, it's definitely going to be 4. No, it's 0. All right, so let's just go ahead and get everything in terms. Okay, so I'm going to go ahead and skip a couple steps here, ladies and gentlemen. I'm going to just say that this is going to be 4xy. And then I would essentially move both these over and notice that they both have a dy dx. So if I want to undistribute this, so over here this would be 12y squared dy dx minus 2x squared dy dx. So I'm going to undistribute this, and so I'm going to go ahead and just put them underneath here. So it's going to leave me with 12y squared minus 2x squared. Okay, so there's my first derivative. The first thing that I want to do, just because it's me, is I want to simplify as much as I can on this, and I'm going to go ahead and just divide everything by 2. So I'm going to just make this going to be a 2. This is going to go away. I'll make this a 6. So let's go ahead and make this a 2 and a 6. Okay, so first of all, big thing right now is I want to evaluate this. I want to evaluate this, x comma y, at 2, 1. We want this value, and you'll understand why here in a little bit of time. So I want the value. So I'm going to go ahead and see what is the actual numerical value for this. All right, so here's the expression, but we're good for that. So now we're going to have the value. Well, when x is 2, and then y is 1, this is going to be 2 times 1, which is going to be 4 on the top. Y is 1, all right, y is 1, so this is going to be 6 times 1 is 6, minus 2 squared is going to be 4. And so we're going to get 4 over 2, which is going to be 2. So remember that the value of the first derivative of this function at the point 2, 1 is going to be 2. All right, it's going to be 2. So we're going to put that in the back of our mind for a minute of time. All right, so let's go and find the second derivative. So now our eyes go towards this. We have to go to this. So here's where we use the quotient rule. Okay, here's where we use the quotient rule. Now, you're probably thinking, oh my God, this is going to be too crazy because we have the quotient rule here, and we also have the product rule that we have to deal with. We're going to be okay. I promise you we're going to be okay with this. It's just good practice. Would I give you something like this an assessment? Absolutely not. No. But again, it's just good practice for us. So what's the quotient rule? So hopefully you guys know that. The first thing I'm going to do is I'm going to start with my denominator, right? So I'm going to go ahead and write down 6y squared minus x squared. And then I'm going to take the derivative of the numerator. And this is where it gets a little bit crazy because we have to use the product rule again, right? So it's going to be 2x. So it's the derivative of the first. The derivative of the second is dy dx. Okay, don't forget that, right? We're still taking derivatives, so it's dy dx. That's the derivative of y plus my second times the derivative of my first. All right, so that's the whole first part of this. I'm going to run out of room here, so I'm going to do minus. So let's just pretend like this is still all of the numerator, right? Minus, and then we want to do the top. And for these problems, I just like to keep everything in parentheses, and then we want to take the derivative of the bottom, okay? And then the derivative of the bottom is going to be 12y, and again dy dx, because we took a derivative of terms of y, minus 2x. Okay, And so there's all that craziness right now. And then the bottom, we're just going to square it. All right, we're just going to take the denominator and we're going to square it. Now, the question is, it's asking us to find the actual derivative, but it's giving us a point. So we want to actually know this value. We want to know what this value is. So here we go, bumpy ride time, but it's going to be not so horrible. So here we go, hear me out. We want to know what the actual value is. Like this was 2, we want to know what this is. Okay, so y is 1, right? So 1, so 6 times 1 is 6, minus, and that's going to be x squared, so x is 2, so that's going to be 4. So then we're going to do 2x, right? So 2 times 2 is 4. Now here is where students make the mistake. Right here, it's 2 times 2, which is 4, but remember, we already know what dy dx is. It's right here, right? Dy dx is 2. So this value is equal to 2. This value is equal to 2. So it's 2 times 2 times 2, which is going to be 8. And then we're going to do plus. And then in this case right here, we're going to do y times 2, right? Y times 2 is going to be 2. And then we're going to do minus 2 times 2 times 1 is going to be 4. I'm just doing some plugging in here. We have 12. 12 times y is 1. I'm sorry, 12 times y. 12 times 1 is 1. 12 times 2 is 24. Minus 2 times 2 is 4. And we automatically already know that this is 2, right? We found that right here, 2, so it's just going to be 2 squared, which is 4. FRQ, ladies and gentlemen, leave it alone. Leave it alone. We're good. But let's look at the problem and just simplify it because, yeah. So this is going to be 2, and this is going to be 10. So 2 times 10 is 20. And then this is going to be 20, right? 24 minus 4 is 20. 20 times 4 is 80. So we've got 20 minus 80, which is negative. So the second derivative is going to be negative 60 over 4, which ends up being negative 15. Okay, negative 15. So my goodness, lots to do there, but we're good with the negative 8, the negative 15. And we'll make sense into what this means and why we care about this. Because now you're like, what? Why are we doing this? We do application problems with this a little bit later on in the course. So hopefully, first video, we're good. Hopefully that makes sense to you guys, and I'll see you in the second video when we do more practice problems if you need them. See ya.